when the scalpel meets the screw. In the shadows, far from the bright lights of the operating room, stands an engineer who never sees the surgeon, never hears the screams of pain, never touches a single bone. Yet he holds a hidden thread that can pull a patient towards life or death. Most people believe the physician alone holds the keys to healing. But behind every incision, every beating heart, every newborn child, stands a design, a duct, a temperature, a ceiling that pushes air downward at a measured angle, all crafted by an engineer's mind. Today, we lift the mask off a startling truth. The engineer can be the reason for recovery or the cause of catastrophe. We will see how air becomes a scalpel, how cold becomes medicine, how humidity becomes a cure or a poison. 1. The Orthopedic Operating Room. In the world of bones, danger doesn't drop from a surgeon's hand. It floats in the air. The orthopedic revelation. When saws and drills cut through bone, no chunks fly as most imagine. Instead, a microscopic dust is born, a white whisper unseen by the eye, yet capable of carrying bacteria deep into the wound. Laminar flow. The air falls from the ceiling like a straight curtain of light, from above to the operating table, pushing everything away from the incision, as long as it stays straight. When air rebels, if that stream collides with a surgeon's head, a nurse's shoulder, or the patient's body, it begins to spin with a hidden physical chisel, thermal turbulence, scooping up bone dust and sending it inward instead of outward. This isn't poetic theory. Studies like Lidwell and papers in the Journal of Hospital Infection confirm that a vertical stream may increase particles near the wound when bodies and tools interrupt its path. 2 truths surgery ignored for decades. Air cannot lift large fragments, but it can drive microscopic bone dust into the wound. Therefore, we see surgeons dressed like astronauts in sealed suits, high-power suction systems kneeling beneath the saw at the moment of first cut, operating rooms designed to sweep air from the sides, not just from above. Here, air isn't background noise. It is a key player holding the fate of the bone. 2. Orthopedics versus birth. The logic of place. Why does the law of air change between a titanium hip and a newborn child? The air's true function, not just to breathe, but to dilute anesthetic gases, to create positive pressure that pushes corridor air away, and to tune humidity as a shield against mold. Why 100% fresh air is no longer sacred. 2 reasons. First, HEPA. Filter 99.97%. Filtered air may be cleaner than outside air. Second, energy. In hot climates, fully conditioning outdoor air requires the heart of a small power station. Different enemies. Orthopedics and implants. A single bacterium nesting on a prosthetic joint can make the body surrender. Often the only cure is removing the implant entirely. Cesarean and birth. The body is warm, alive, blood-rich. Its immune army arrives fast and devours intruders. Thus, maternity guidelines allow air recirculation, even if only 4 of 20 air changes are fresh. The new equation, not where the air comes from, but how many times it is renewed and how pure its soul becomes. 3. Burn units. when air becomes medicine. In burn care, air isn't comfort. It is a treatment as vital as morphine. The skin, a fallen wall. When skin burns, the body loses its greatest gatekeeper. Fluid escapes. Cells die at the slightest dry breeze. Evaporation, the silent assassin. Every gram of evaporated water steals body heat through an unforgiving law of physics. Latent heat of vaporization. The body burns calories, not to heal, but to stay warm enough to stay alive. The humidity gold zone. Below 40%, cell death, energy hemorrhage. Above 60%, fungi dancing on the walls. Thus, the sacred range, 40 to 60%. Some intensive care units create microclimates around the patient's bed without contaminating the whole room. Temperature, 24 degrees to 32 degrees Celsius. Oppressive to us, but to a burn patient, it is an embrace of survival. 4. Cardiac patients, where air dances with arteries. Here, air becomes a partner to fluid dynamics. When the cold oversteps, vessels constrict, resistance climbs, the heart strains, and angina stalks like a knife in the dark. When heat surges, vessels widen, blood pressure drops, the heart races to compensate. Sweat drains fluid from the blood, making it thicker, more eager to clot. The deadliest moment, not cold nor heat, but the jump between them. A thermal shock can bring a weak heart to its knees. Thus, in the coronary care unit, temperature is not a preference. It is a rescue plan. 20 to 24 degrees Celsius, where the heart rests, arteries behave, and the body breathes in peace. Now we enter the realm of pressure. The hardest concept in hospital engineering is not temperature or airflow rate, but pressure. In medical HVAC, pressure is not a number. It is a battlefield tactic. Sometimes we trap the virus inside a room. Sometimes we barricade the world outside. Sometimes we build a double defense, like a submarine airlock. Thus, 3 architectural philosophies emerge. First, negative pressure room. AIIR, Airborne Infection Isolation Room. WHO, COVID-19, tuberculosis, measles, airborne diseases. Mission, trap the monster inside. A contagious patient. Engineering commands, let the disease stay imprisoned within the walls. How it works. More air is extracted than supplied. V exhaust, V supply. A vacuum-like pull forces corridor air in, not the other way around. Critical outcome. When the door opens, air flows into the room, and not a single bacterium escapes. Golden rule. Contaminated air is not dumped outside. It is filtered or exhausted high above intakes, or passed through HEPA filter. Here, the engineer becomes a gatekeeper, guarding the hospital from invisible invaders. Second, positive pressure room. PE, protective environment. WHO, immune compromised patient. Chemotherapy. Bone marrow transplant. Severe burns. Advanced immune disorders. Mission, shield the patient from the world. This room never imprisons disease. It is a fortress against microbes. How it works. More HEPA-filtered air supplied than removed. V supply, V exhaust. air pushes outward into the corridor. Engineering philosophy. When the door opens, the room exhales. It never inhales. Here, air fights on the patient's behalf. A silent knight in a sterile armor. The dual risk paradox. Hybrid plus anteroom airlock. A contagious patient with no immunity. Rare example. Tuberculosis patient undergoing chemotherapy. Shedding pathogens and defenseless against them. Negative pressure alone fails. Positive pressure alone kills. We need a hybrid masterpiece. Not a neutral pressure room 0 pascals is a myth. Unstable and dangerous every time a door swings open. The real solution. The anteroom. An engineering piece of magic. A buffer space between two worlds. How the system breathes. Patient room. Negative to the anteroom, keeps infection trapped inside. Anteroom. Positive to corridor. Positive to patient room. Redirects airflow and stops two-way contamination. The airflow logic. Corridor to anteroom, not to patient. Anteroom to corridor pushes contaminants outward. Some clean air to patient. Patient exhaust to outside hospital. Genius outcome. Protects hallways and staff. Protects the patient from hospital-bred microbes. Turns ventilation into an airlock like submarines and space stations. The engineer's hand in healing. A hospital is not doctors alone. The surgeon saves the patient when he stands beside him, but the engineer protects that same patient before he arrives and long after he leaves. The engineer commands the air he breathes, the pressure that shields him, the humidity that blocks fungi, the temperature that keeps his heart beating, and the filters that stop an unseen microbial universe. The unseen cure. On stage, the surgeon stitches flesh, cuts bone, revives the heart, brings a child into the world. But behind him, another mind works in silence. The engineer designs the theater. The light, the air, the humidity, the pressure. If the doctor errs, one patient may fall. But if the engineer errs, an entire system may collapse, perhaps without anyone knowing where the failure began. Thus, medicine and engineering meet. One works inside the body, the other shapes the space surrounding it. In the end, healing is never the doctor's decision alone, but the harmony of minds that never occupy the same room. A scalpel that opens the body, and a design that protects the soul.